Hello, my name is RD and the question is determine IB in the circuit in figure 3.58 using nodal analysis. Okay, we are given the clue here that we have to use nodal analysis. And let's break it down step by step on how to do nodal analysis. Nodal analysis. The first step that we need to do is to first label all the nodes and then extract information that we can get from it, right? And here we have this node here. Let's set the bottommost node here as our reference or ground node. And what does that mean? That means that the voltage in this node here is equal to 0, right? And we have one essential node here. Let's name this node here as node A. Thus, the voltage here is VA. Good. And here we will have this voltage source here. And the difference between the negative terminal, which is 0 here, because it is connected to the reference node, and the positive terminal should be 24. So here we have 24 volt from the ground because this is voltage source. Okay. And then what can we do? Next, let's move on to the second step. We need to assume the current's direction. The current's direction. Okay, let's assume the direction of the current. We are already given that IB goes to the right. And then maybe this one will be goes down. And this one here goes to the right. And eventually it will turn goes down here. However, we cannot calculate this current here. But fortunately, it is in series with this one. So this current and this current is the same, right? So we can calculate via this current here, but for that, we need this value here. So here we will have PA minus this value here. Why? Because the difference between positive terminal and negative terminal is the magnitude of voltage source. So I will have PA minus 60 IB on this node. Good. And I think we are all set here to do the third step, which is the most crucial step, which is to do KCL for each nodes. Let's see what can we do here. We need to do KCL at node VA here. Let's see KCL at node VA. Okay, KCL said that the sum of the current that goes in will equal to the sum of the currents that goes out, right? And the only current that goes in is this one here, and we will get that as IB. Let's write that. So we'll have IB there, and that will equal to this current here. Here we will have VA. VA is where the current comes from, and then minus 0 because the current goes to the ground, so we'll have 0. But we need current, so we divide it by the resistance between them, which is 50. Good. And now we will have plus. We cannot calculate from this one, but we can calculate from this one. And that current here is where the current comes from, so we'll have VA minus 60 IB, and then minus 0. And we need to divide it by 150. Good. Now let's simplify things here. We will have IB is equal to VA over 50, and then plus VA minus 60 IB over 150. Good. Now what can we do from here? Multiply both sides by 150. 50 and 150 will cancel into 3. So we will have 3 VA here. And here 150 and 150 will cancel each other. So we'll have VA minus 60 IB. Good. Now 150 multiplied by IB, that will be 150 IB. Good. And now we will have 221 IB is equal to 4 VA. Or we can isolate for IB. So we'll have IB is equal to 4 VA divided by 210. Good. Now we have IB here, but what is IB? IB is this current here. Let's calculate that. Okay, let's calculate IB. IB is equal to 24 and then minus VA divided by 250. Good. And now let's multiply both sides by 250. So I'll have 250 multiplied by IB, and that will equal to 24 minus VA. Okay. Now what can we get from here? Let's substitute this IB here with this one here, right? So we need to calculate VA first. Or we can calculate via AB. Let's do another substitution then. Let's isolate VA instead. So we'll have VA is equal to 210 IB divided by 4. Okay, so instead of substituting IB, we substituted for VA. So I will have 250 IB, and that will equal to 24 and then minus this one here. So we need to substitute VA into this value here, which is 210 IB divided by 4. Okay, I ran out of space. Maybe let's clean up something first. Okay, we can multiply both sides here by 4. Right, to get rid of this 4. So I will have 1000 IB on the left hand side, and that will equal to, I will have 96. Here 24 multiplied by 4 is 26, and then we will have minus 210 IB. Let's isolate AB. So I will have 1210 IB, and that will equal to 96. Good. And what is IB? IB is equal to 96 divided by 1210. And that will be, let's calculate that. 96 divided by 1210, and we need the decimal value. We will have 0.079. 0.079 what? 33 or 34, and the unit here is ampere, and we can convert that into milliampere, and we will have 79.34, and the unit here will be in milliampere, and that is the value of IB, which is quite tricky to find. Hopefully this will help you to solve this problem. Thank you for watching. See you in the next video. Bye bye.